Hello, here you can see the first and our simple architecture. As you can see here, we have a 5G device that sends queries to our edge beacon and also to our beacon server in AWS. We have three different protocols for latency. As you can see, ICMP, TCP, and HTTP. And also we send queries from our edge to our beacon. After that, we have another architecture. Here you can see the internal latency of the network. As we are member of Anchor Network, we have edge sites in 5 different cities in Canada: Waterloo, Toronto, Ottawa, Montreal, and Quebec City. As you can see, we can calculate the latency between these different edges, and also we have different devices just in Quebec and Montreal site, and we calculate the latency between these devices and our beacons in Azure and AWS. Also, here I want to show you our compact dashboard. As I told you, we have ICMP, TCP, and HTTP. These are real-time protocols and data. And also we can see the historical data of these three here. So we tried to aggregate these three number to one number. So here you can see the aggregated latency of one device. And also we have the aggregated reliability according to the packet loss of that device. And also we calculate the incoming and outgoing bandwidth of the network, of the interface of the network. And also we have the trace route here and the number of hops between our device and our beacon. We try to collect as much as data as possible. Here you can see we collect the health of the device, CPU, RAM, disk usage, and also the incoming data and outgoing data during the day. Also, this is the running time of our servers. And also we have alerting systems for them if they pass the threshold of their usage. So the network admin can understand that there is a problem in that servers. As I told you, we collect as much data as possible. So here we collect environmental data like the distance between our device and our beacon servers. This is a one-way distance. And also the weather status, temperature, and witness speed, which are affect the RF signals of the 5G network. After that, we have some dashboards that show our parameters of uh, comparative analysis. As you can see here, we have three devices. The first one is connected to 2.4 gigahertz Wi-Fi connection, which is connected to 5G modem 3.5 gigahertz. As you can see, the latency is around 50 milliseconds. The second device is connected with fiber network, fiber cable to the 1 gigabit per second Bell network. As you can see, the latency is significantly low. And here you can see the third device, which is connected with Ethernet cable to the 5G edge network. And as you can see, the performance of 1 gigabit per second fiber network is the same as edge network. After that, we have another dashboard that shows the composition of the latency. So we try to break down as much as possible the components of the latency. Here, for example, we have propagation delay. As you can see, this is 77% of our latency. We have unknown part, routing delay, transmission delay, processing delay, and queuing delay. And we are trying to optimize these parameters so we can minimize this unknown part. Finally, we had this part is under development. So you can see here, we want to have a predictive analysis of that data. So according to the use cases of the clients, we want to predict the latency for example, 1 hour, 1 day, or 1 week with a reasonable threshold for our clients.